open book. I want you to write correct proofs. So I have to write this. I have to write this. Because these two happen, I can use MVT. And because I can use MVT, MVT will guarantee that C in the open interval -2, 2, such that this relationship is fulfilled. And then we step by step solve for C. Again, at the very end, I have to show that what I found is in the given interval. Because we had an example in which one worked and the other one didn't. One was in the interval and the other one wasn't. In this case, both of them are. Very good question. Anything else? Who is next? Other questions? If you need any help with WebAssign, anything, or I will choose. Okay, so for test 3, we should see problems like, why is this not? Okay, good. So we should see number 1, of course, situations with critical numbers. Number 2, study the function on a closed interval. In other words, finding max min. This is mainly for absolute max min, but I will also ask you to identify which ones are relative max min. Number 3, roles plus MVT, which we just did. Number 4, graphs. Exactly what we just did. Number 5, L'Hopital. And we had one. Number 6, Newton's method. And number 7, and the last one, optimization, which we have to work on more. What would you like to continue with? The floor is yours. If not, I will choose. Do you need help?
Sir, I don't know if I missed something, but are we not covering 4.9?
4.9 is part of chapter 5. 5.1, 5.2, 5.3, 5.4, 5.5. These are together. 4.9 should not be in chapter 4. Should be in chapter 5.
You're right. I assumed it was when I was looking at the WebAssign stuff, but the dates are not the same.
No. 4.9 is something else. I don't want to confuse you with that yet. It will be confusing. Sure. It will be a little bit confusing at the beginning. So that's why I won't even mention it, what it is.
Can we do some more optimization?
Yes. Very good. I am just opening on 4.7. I have the book right here. Okay. I would like us to look at those with, where's my book? Okay. Okay.
Should we expect to see these types of questions with the trig stuff as well?
You mean trig in the optimization? Are we talking about the optimization?
Yes.
Sure. Yeah, so we're going to look at several. Okay, so here's a very simple situation. Find the dimensions of a rectangle. I will read a few and you choose. Find the dimensions of a rectangle with an area of 1,000 square meters, whose perimeter is as small as possible. So we are minimizing the perimeter. In problem 9, luckily, we are given the function. See, in this problem, we are not given the function. So the function we want to minimize, which is the perimeter, we have to work and get it. And then from that point on is easy. In this problem, we are given the function. What nitrogen level gives the best? By the best, we mean a maximum. Best yield. So we are maximizing the yield. So the same thing here. The photosynthesis, we are given the formula. We are asked to find maximum of P. Anything interesting? Yes or no? We move on if you say no.
I think those ones are pretty straightforward. Like you said, max and min of simpler concepts.
Okay.
I think I'm not comfortable with my trig, so I think if we could look at one that has some trig in it, that would be great.
So let's see if we find one with trig per se.
I saw 53 has some trig in there. I didn't get to read the whole thing though.
Let's take a look. 53 you said? Let's take a look at 53. Okay, so let's take a look. In a beehive, each cell is a regular hexagonal prism. Okay, over at one end, fine. At the other end is capped by 3 congruent. Okay, fine. We don't have a graph. Oh, we do have a graph. Thank you. Yes, here it is. Okay, but they're given us the function, so we don't have to really do anything. They're just showing us what they are talking about. Fine. Let theta be the angle at which rhombus meets the altitude, s the side length of the hexagon, and age be such and such, base of the trapezoids. Okay, they're explaining to us how they came up with this formula. And here's the formula. The value, okay, the surface area S of the cell. So here it is. So you want to work on this?
Yeah.
Perfect, 53. So S equals 6SH minus 3/2 S squared cotangent theta plus 3/2 the square root of 3. I'm assuming that's divided. That's a very bad way of writing it. Okay, cosecant theta. Okay. So in such a way as to minimize the surface area, thus using the least amount of wax. Okay, so they're asking us to calculate ds over d theta. Very interesting and very clear, I would say. They're telling us that only theta is the variable. Everything else you can disregard. Not disregard, but we are only differentiating with respect to theta. So in part 1, ds over d theta. Okay. So let's look for one more second. So age is the height. Okay. What is little s? Again, what was little s? The side length of the hexagon. Okay. And age, the length of the longer base. It can be shown that if they are held fixed, then the volume of the cell is constant, and for a given value of the surface area. Okay, so these are all kept constant. Got it. So when we differentiate with respect to theta, there is no theta here. So there is theta here, and there is theta here. So when I differentiate this, I get 0. When I differentiate this term, I only get negative 3/2 s squared, and I have to differentiate cotangent. Anyone remembers how to differentiate cotangent?
Negative cosecant squared.
Yes, negative cosecant squared. Theta, good. Plus 3 the square root of 3 over 2s squared. And now we want to differentiate cosecant theta. Anyone remembers the formula for negative cosecant theta prime? It's negative cosecant cotangent. times, you should continue here if you have space, but I didn't have room enough room over there. Okay, so that was the first question. They were asking us to find ds over d theta. We did. What angle theta should the bees prefer? So it says we're asked to minimize the surface area. So
find the minimum for this function.
So in order to minimize this function, first of all, I have to set it equal to 0, and then find the theta for a minimum. Okay, perfect. So let's set it equal to 0. See what happens. Looks interesting. Okay, I'm on page 7. So ds over d theta equals 0. So first of all, I have a positive here, so 3/2 s squared cosecant squared theta, and minus 3 the square root of 3 over 2 s squared cosecant theta cotangent theta equals 0. Now, I'm assuming this s squared is in the denominator, but I'm not certain. Let's look again. Is this how you understand? This is a very bad way of writing it. Very bad.
In the printed textbook, there is not a / there, and it's just square root 3 s squared.
Because, see, I will not be able, if it's in the denominator, I will not be able to simplify it. So, okay, which page is this one? Okay. Yeah.
345.
Yes, you're right. I just see it here. I just see it here. There is no. That it made no sense. It made no sense to divide. So I already told you about that typo. I sent you an email. I don't remember which problem it was. It was that kind of gibberish. Okay, so this made no sense. So I have to correct it here. Because, see, this s squared will go away if it's in the numerator, but it will not go away if it's in the denominator. But thank you for noticing that. In the ebook, it's a different story, which makes no sense. Okay, so there is an s squared here, and there is an s squared here. I see where we're going. I don't know the answer or anything, but I see where we're going. And it's s squared here. Okay, so we corrected it. That's very interesting that that slash got in there in the way. Okay, good. So that's better. So in order to solve this equation, let me stop sharing. Okay, we made the corrections with s squared. Thank you so much for doing that. Now, obviously, I will have to factor out the cosecant, and I definitely have to divide both sides by s squared. And I will divide actually both sides by this. So 3 over 2 s squared and 3 over 2 s squared. So imagine that we are multiplying by 2/3 over s squared, both sides. So we clean this up. So we have cosecant squared theta minus the square root of 3 cosecant theta cotangent theta. This looks much better, much better. Okay, so now I will factor out a cosecant theta, and I have cosecant theta minus the square root of 3 cotangent theta equals 0. Okay, so two pieces. First, this. So cosecant theta equals 1 over sine theta, which can never be 0. Okay, now the second one. Cosecant theta, 1 over sine theta, minus the square root of 3. Cotangent is cosine theta over sine theta equals 0. Multiply both sides by sine theta. So finally we get 1 minus the square root of 3 cosine theta equals 0. I move 1, divide, or move this and divide. So I have cosine theta equals the square root of 3 over 3, because it's 1 over the square root of 3 and rationalized. And if you remember, I always tell my students there is no need to over 3. Well, we don't have an answer here. I just have to apply cosine inverse. We know the square root of 3 over 2, but we don't know cosine of the square root of 3 over 3. Unless, again, these numbers, let's check those numbers again. It was negative 3/2 s squared, yes. And yes, again, let me look at the book. 3/2, yes, that's 3/2. And the square root of 3. Yeah, I think the numbers are okay. And there was cosecant, yes, and cotangent. Okay. So
I'm curious about us multiplying by sine theta, since the other side was 0 and theta is what we're solving for.
yeah, but it's in a denominator. It could never be 0.
Right, okay.
So that's why I multiply both sides by sine theta, because sine theta cannot be 0 anyway. It's in the denominator. If it's 0, then the whole thing collapses. There is no function.
Right, okay.
Okay, I just wanted to make sure so cotangent, that was correct. Cosecant, that was correct, yes. I'm not getting an angle that is known. Okay, that's fine. It doesn't have to be. But I'm just double checking my calculations here. Cosecant, cosecant minus cotangent. Cosecant is 1 over sine. Okay, minus the square root of 3. Cotangent, cosine over sine. So cosine is 1 over the square root of 3 over the square root of 3 over 3. Okay, fine. So that means that I'm on page 8. Let me see what I'm on time. Yeah, that's good. Okay, so then theta equals arc cosine the square root of 3 over 3. So now I have to show that arc cosine the square root of 3 over 3 s prime of theta and s of theta, that this gives a minimum or a maximum or whatever that is. So I don't know what it is. Where is my derivative? Okay, the derivative was here. So I have to approximate this and see what it is, just to have an idea. And then I have to plug in the derivative, where is simplified, right here, okay, and see if this gives a minimum or a maximum, because I can't guarantee. This number is the same, so I only need to plug it in here. Okay, so with the arc cosine, quickly I'm gonna just put arc cosine. Make sure that you have it in radian mode. Okay, so cosine inverse of the square root of 3 divided by 3. So I got 0.96 radians. Okay, if this is 0.96, I'm going to plug in 0.8. But I have to put the function in. So in y equals, oops, I didn't mean to graph. Oh no, I didn't want that. So in here, I want to put in cosecant squared is 1 over. Just this alone, plugging it in, it's cumbersome. So sine x squared. Okay, minus the square root of 3. And then we have 1 over, what do I have? 1 over sine and cosine over sine. So cosine divided by, again, sine squared. So sine x squared. Okay. And now when I plug in here, what was it? 0.96. I may not get exactly 0, but I should get 0. Close, close. So now I'm going to plug into the left of that number. So like 0.8 and see the sign. Okay, negative. Yeah, that's what I was hoping for. And to the other side, I'm going to put 1.1. And it should be positive. Yay! Okay. So we showed that indeed this is a minimum. If they're asking us whether it's what it is, I will not be able to determine it because of that s squared. I don't have that s. I don't have that. I don't have the s and the h as well. So I cannot determine this number. This cannot be determined unless they give us s and they give us h. Then we can plug it in. Okay, next. What do they want? What else is there? Oh, so determine the minimum surface area of the cell in terms of S and H. Okay. So, so S, all I can do is just plug in the numbers. So it's 6xh, which I don't have, minus 3/2 s squared. And then I have to determine cotangent of this 0.96, fine, plus 3, the square root of 3 over 2, s squared, and cosecant of 0.96. So I don't know if they want numbers. We can determine this, and we can determine this. But that's the minimum. This is the minimum, this whole thing. So the cotangent of 0.96 is, and cosecant of 0.96 is. So let me do this with a calculator. Okay, so we want cotangent is cosine of 0.96 divided by sine of 0.96, and that is 0.7, and the other one is just 1 over sine of 0.96. So this is 1.22. So this is what we have to plug